So let's take a look at direction fields. Now, direction fields is not a very common topic that you'll be seeing in the IB, but it's definitely something that you should note of. So if you see on the left side here, we have this funky looking diagram with these red lines. And we have this equation, this differential equation that we are trying to visualize the direction fields of. So we get y prime equals x, and that means every x coordinate also means that it is the slope of the tangent at that point. So when x equals to 0, y prime equals to 0, and that's why we get a horizontal slope on every point of x equals 0. And then, if you look at the chart here, I have listed out all of the relationships between x and y prime. So let's take a look at when x equals to 1. That is when y prime equals to 1. So in this column here, we see that the slope is equal to 1. And then at 2, it gets steeper, and at 3, it gets steeper, right here. And then it's the same thing for -1, -2, and -3. And you get this general shape. Now, by looking at this, what you're actually able to do is get a glimpse of what the graph is going to look like. So, from my understanding, this is going to look roughly like it's going to go like this, and then it's going to start going up, and then it's going to start going steeper and steeper and steeper. And of course, it's going to be the same other way around. So you start going to the left, and then you start going up steeper and steeper and steeper, like that. So I would be convinced that this is actually what the graph of y would look like. And we can very much confirm this because the value of y here is 1 over 2 x squared. So yeah, when you have direction vectors, direction fields, you get a glimpse of what the original equation would look like. Get the graph, and then you would kind of get an idea of how the graph would look like. Yeah, and that's pretty much it.